Hello and welcome back to the Inside Java podcast, a podcast about everything Java, brought to you by the team at Oracle that builds Java. My name is Nicolai Parlog, and today's episode is a bit of a continuation of the last one, where we talked about integrity by default, which manifests itself as new command line flags to unlock certain operations like deep reflection, as well as the removal of certain operations from sunMISC unsafe. And it's the latter thread that we'll pull on a bit more today to learn about other deprecations and removals, for example of 32-bit ports and finalization, although these are unrelated to integrity. And who better to talk to about that than Stuart Marks, but not in his role as member of the JDK Core Libraries team at Oracle, but dressed in a lab coat and wearing a stethoscope, thus embodying his alter ego, Dr. Deprecator.
Yeah.
What's up with that?
What's up with that? Okay. So I'm Stuart Marks. I work in the Core Libraries team in the JDK group at Oracle. I go by Dr. Deprecator because one of the things is I work on deprecating and removing stuff. And, you know, everybody's talking about adding the latest features, and that's all great. We, lots of teams do that. Yeah. But we also need to take stuff away, and that's not as it's not as fun. So I'm trying. So I created Dr. Deprecator to try to liven things up a little bit.
Oh, so you try. Okay, I thought you would create like an alternative personality to blame them. I'll be like,
no.
That's not my fault. It's his guy's fault.
Yeah, no, but Dr. Deprecator is a surgeon, so we are very careful about how we remove things, and we use a scalpel to remove the old things very carefully.
Yeah. So some of the things that are getting removed or in some contexts disallowed, I already talked to Ramprester about under the umbrella of integrity by default. That means the sunMISC unsafe memory access methods at the moment are deprecated for removal, but sunMISC unsafe in general is going away. And then there's some things that will still remain in place, but they will be disallowed by default. But we are here now to talk about things that will be really just like hardcore removed, that are currently being deprecated for removal or already deprecated. And I think we brought 4 topics. We're going to do the first ones quick, and then we're going to spend a little bit more time on the last ones. The first one we had is 32-bit ports. Right. So maybe you can talk a little bit about that. I think at the moment in 24, the Windows 32-bit x86. Oh my God.
Yeah, it's not x64 anymore.
Yeah.
It's x86. Yeah.
Yeah. So that one is gone already.
That's gone, and Linux is going to go next.
Yeah. Right. So maybe talk a little bit about.
Well, yeah. I mean, there's not much to say. It's like, if you buy a mainstream server machine or some kind of desktop or laptop or something, there's no 32-bit anymore, which is pretty amazing because I remember when 32 bits was the new thing, right? But those are obsolete in the mainstream. Now, I'm sure there are 32-bit computers out there somewhere that people want to run Java on, but actually one of the practical problems is, when we check in code to the JDK, we have a continuous build and integration system. We run, 8 builds and run thousands of tests and stuff. Finding 32-bit machines to run in that environment is actually really hard.
Oh, I never thought about that. Okay.
Yeah.
True. You need 32-bit hardware to test all that.
Yeah. And so it's all aging out. And so all of that stuff is years old now, and it's hard to keep up to date. And so, so I'm sure somebody somewhere probably wants to have a 32-bit port, but, we're taking it out of the main line because we just can't maintain it.
Yeah.
Or it's not, we could, but it's just too expensive to maintain.
Yeah. Are there also some features that are just implemented like in a rudimentary way in 32-bit? Wasn't like something like the virtual threads on 32-bit?
Right.
There's like basically like a shift, so they work correctly, but they don't do like the full virtualization thing.
Yeah. I mean, there are some things like that where there's obviously the code generation stuff, but actually switching of virtual threads is something that requires going down fairly low level of the hardware. And so it's like, okay, well, do you really want to maintain a separate 32-bit version of that code? It's all done in native code.
Yeah.
And it's like, well, it's just yet more stuff to maintain.
Yeah. I mean, that's the point, right? Like if resources were infinite, sure, why not? But they're very
finite. They aren't.
So any minute spent there is not meant elsewhere.
Right.
Okay.
Exactly.
The next thing on the list, I think, is applets.
Yeah.
So why though?
Why remove them, or why are they still around?
Well, maybe the latter. So I already talked to Michael on yesterday's streams. I already said that was actually the first thing I did. I learned after I learned Tour Pascal in the end of high school. The first Java we did was actually an applet. Yeah. I think we did something. People like a restaurant plan, like people sitting on a table, and it was like in a browser. It's very dimly remember. So it was my first Java actually. So why do you take them away?
Yeah.
I have
I know. Applets were the big thing in 1996.
Yeah, that's a little later when I learned about them. Yeah. Okay.
Yeah. Okay, well, all right. So there's a bunch of reasons. People don't run Java applications in their browsers anymore. Yeah. Most of the mainstream browsers do not have the capability to run a JVM as a plugin anymore.
Yeah. It's a matter of like, can they, but won't they do that? Because I think it's like, isn't it like a sandboxing, like browsers have become much more security focused. That's not the reason. I thought that was the reason why they were going.
Yeah, I don't know the exact thing, but it's just, you know, applets were very popular for a few years, but then they kind of tailed off. And then after a while, the browser support was removed from them. And so
then I just made the decision, right? Like, why maintain this if nobody using it? They also
I think so.
time.
I think so. And I certainly don't blame the browser vendors, but also, you know, the fact is, you know, Java's focus moved away from applet stuff to running, you know, enterprise applications on the server side. So our focus was elsewhere as well.
Yeah.
But surprisingly, it's like, here we are in 2025. Why are applets still around? There is a very long tail of usage of applets still in there. And I actually don't know what
do you mean in where?
Oh, I mean, in the entire industry, right?
Okay.
Customers, in our customer base, right? So, you know, I'm not even going to guess about any numbers, but there are, we've been trying to remove applets for a long time. They were actually deprecated. They were initially deprecated not long after JDK 9 when the new deprecation stuff came in, but they weren't deprecated for removal until fairly recently. And then now actually the team is working on removing applets.
Yeah,
I mean, for real.
Yeah, there's an issue on that is so far not targeted yet. But I put it on my slide. So there's like there's the JEP that announces the deprecation for removal. It's at 23 or 24 or something. And then there's a ticket already that says remove it for real.
Yeah, and so it's like, well, how hard it is to remove applets? Well, removing applets itself is not that hard, right? All they have to do is take it out of the API and cut some stuff, just some code cleanup. The real problem is the tests. So the desktop team has a whole bunch of tests that are written essentially using a kind of a homegrown test framework that uses applet. Okay. So they have like thousands of tests that they have been slowly working on. Well, I mean, not that they're working slowly, but they have been working the way through them. And there are thousands of tests. There's a lot of tests to work through. They have to, and you know, I'm sure they would have investigated an automated refactoring if they could, but I think that it just hasn't been in the cards. So they just said, okay, let's just do this manually and work through it over the period of a few months, basically rewriting those tests to do some alternate things.
So is there some poor JDK engineer that just like goes to work and just
there's a team
just moves tests over all day long?
This is the client team in the.
I'm joking. Like, how many people are continuously doing this though? Because it sounds
4 or 5 people actually.
But all day, every day.
Well, not all. I think, you know.
I'm hoping from that note, because that was the job. Because that sounds like terrible work, like week after week of just.
No, I think they're chipping away at it. I mean, this is kind of the things. You have a big task. You spread it among a few people. Everybody spends an hour a day working on some stuff or something. I don't know exactly how they're working on it, but I think they're working on it over a period of time because there's just a lot of stuff to do. And the thing is about these tests, they're not tests of applet. They're tests that test other stuff that is still valid functionality. It's just that they use applet in the test framework that they're using. So they have to rewrite all that stuff to extract the stuff away from applet before they can actually remove applet from the JDK. So
I mean, this occasionally happens. I know of cases, for example, when you one way still to draw stuff is just create a swing 2D canvas, draw stuff in there, get a PNG out of it. So I know it's not like apparently unrelated technology can end up being actually a good way to achieve something else. But then you use of the technology still, and if that technology's original use case is going away, you might end up in a situation where, well, now the thing you're using indirectly also goes away. Okay, let's go to the 2 big ones: finalization and the security manager. Pick one.
Okay. Well, we'll start off with finalization first, because we'll save the best for last. Actually, security manager is nice. I like to talk about that. But finalization, we've been working on for a long time. Gosh, where do I start? So
what is finalization?
Okay. All right. Yeah, that's where I should start. All right. So finalization was a feature that was added. It's been in Java since the very beginning, all the way back to 1.0. And basically, so Java has a garbage collector, and the garbage collector normally works behind the scenes, and it basically reclaims the memory consumed by objects that you aren't using anymore. So how does the garbage collector know that you're not using it anymore? Well, basically it walks all the objects and says, oh, if there are no more references pointing to this object, then clearly this object cannot be used. And so we're just going to reclaim the memory and use it for something else. And so in a normal regular Java program, you just never notice that, because if you're not using an object anymore, you don't have a reference to it, so you can't tell whether or not it's gone away.
And the object, technically the object doesn't know that it's not referenced anymore. It doesn't know it's being collected.
Yeah. Okay. So, but there's this problem, which is sometimes we use objects to refer to things outside the JVM, like we have an open file or a socket or something like that. And so in that case, the garbage collector can reclaim the memory, but the garbage collector doesn't know how to close the file.
Yeah.
And so over time, your program will build up with open files and eventually run out of open files and your system will stop working. So a misguided effort in 1.0 was added prior to 1.0 to deal with this issue, which was finalization, which is, okay, when an object becomes unreachable, when there are no more references to it, instead of just being reclaimed, then the JVM calls a method on it.
Yeah.
Now there's this weird thing, which is when you call a method on it, it's reachable again, because now you have a running thread that has a reference to this object. Now, so that's kind of okay. If you just do some cleanup and then return, you're fine. But there are all kinds of bad things can happen if you plug this back into an object graph and so forth. And there's the JEP, I forget all the JEP numbers. Is JEP 421 that does finalization?
I'm not sure. We just talked about this as well.
Yeah, we got to look at the JEP number.
It's fine.
But anyway, so the JEP explains a bunch of stuff in here. Actually having finalization in the system is kind of dangerous.
Yeah. So one big thing, for example, is that you don't know when that happens, right? Like the garbage collector is intentionally non-deterministic. You don't know when people get garbage collected, so you don't know when the cleanup happens. So you might still run out of file handles,
right? Because
the garbage collector just didn't.
Yeah, actually, that's an excellent point. Thanks for bringing that up. Because so you have a running system. Suppose you use a file, you open a file, use it for a while, then close it. Okay, so normally you're doing a bunch of tasks, you're opening and closing files constantly. And so suppose you had a system where, because of error handling or just because of programmers write bugs, they somehow forget to close the file. So you might open a file, might open a file, store the file descriptor in the object, use it for a while, and then let that object become unreachable.
Yeah.
So you still have an open file descriptor in the system, and it will eventually, the garbage collector will come around, notice, call the finalizer.
Yeah.
But meanwhile, you're still opening more files.
Exactly. Yeah.
And at a certain point, the total number of files, might go up and up and up. And in fact, the rate at which you open files might outstrip the rate at which the GC runs the finalizers to close the files. And if that's the case, then you will run out of file descriptors, even though they should be garbage collected. So that's another one of the problems, which is finalization there's no timeliness guarantee on finalization. And so it's basically a producer-consumer problem. Your producer can outstrip the consumers.
Yeah. So and so I think the main flaw there is what you said, why it was like a mistake to do that, probably is because garbage collection and resource management, it's not entirely unrelated, but pretty much there's a very different concerns. And so meshing these concerns together leads to these results, because the garbage collector wants to be lazy, it wants to be non-deterministic, it wants to say, I know best when to do things. But at the same time, you have the application who has like a vested interest in knowing when things get collected, or rather when things get cleaned up, which in this mechanism is finalization. Right, so people who use Java not for like 2 decades, they're all thinking like, what is it talking about? Why don't you just use a try with resources block, which is exactly where that thing exists.
Right.
Because that's just the better solution in all the cases where it is applicable. Just use try with resources.
Right. Well, like you said, there's this key caveat.
Where it's applicable.
All the cases where it's applicable. Yeah, so try with resources, in general, there's a large number of patterns, but not all of them. You open a file or open a socket, use something for a while, and then close it.
Yeah.
But there are times when you want to leave something open and then have, like with a network connection, you leave that open as long as the requests are coming in.
Yeah.
And if requests don't come in for a little while, you park it in data structure and then wait for some activity to come on it.
Yeah.
So you have to write your program very carefully to say, okay, nothing's come in on that for a minute, so we're just going to close it.
Yeah.
So you have to have something that comes in and does that. And you have to write that code explicitly.
Yeah.
But Finalizer or some other similar GC based API is not going to help you with that. You really have to write that code correctly yourself.
Right, so that explains why finalization is kind of like a dangerous to use feature that can easily mishandle and doesn't really do what you want to do, and that's why there have been introductions of other mechanisms. We talk about private resources. There's also the cleaner API, which I think we don't have the time to go into, but they're also there for those cases that are left over, basically. So finalization, that explains why finalization isn't needed anymore, but there's more than that, right? Like it creates overhead that garbage collectors need to track, and so it's like a constant maintenance.
So there are a bunch of semantic problems with finalizers, because one of the fundamental to it is, if an object, you want an object to move through its life cycle in a forward fashion only. So the fact that, oh, this object is now unreachable, then we're going to call a method on it, which effectively makes it reachable again. So that's a problem. And in fact, it's possible for programs to use that phenomenon to create, to exploit security vulnerability.
Yeah, to resurrect objects and
it's probably a little too detailed to get into here, but it's a problem having it in the system. Another problem is that even if you have an object, I mean, it's more of a performance issue. If you have an object that represents an open file, even if suppose you open it, use it for a while, and then close it, great. So it can just be garbage collected now. But if it has a finalizer on it, the GC still has to track it, call the finalizer, and all the finalizer does is say, oh, it's closed already, I don't have to do anything. And that just creates more overhead. And so it would be nice to get rid of it, because the GC guys, have been carrying around this mechanism since day one that they have to support and has to work correctly and stuff.
I think ZGC I think there's a number in the JEP. This is like ZGC's overhead. Like 1% of ZGC's, overhead is like what ZGC does beyond just the objects that it has to maintain. There's like a percent of that. That's just tracking finalization.
Maybe.
I think something is in the JEP. Yeah. Okay, so that's by finalization. So it's deprecated for removal at the moment, right?
All right, so I'll tell you the current status of that is, I haven't done a survey of how much. I think there are finalizers used in, open source projects and so forth. But actually, probably the biggest user of finalizers is the JDK itself. And okay, so here's the thing. So we've been slowly removing. So we don't want to remove finalization until the JDK actually doesn't use it itself. Okay, so we're working on it.
Fair enough, I would say.
So of course, the easy ones have already all been removed. Okay,
so left with Dr. Deprecator is now left with all the tough.
Yeah, well, I mean, it's not like I'm doing all the work myself. Okay. But yeah, we have people working on this as well. And it turns out that the most of the finalizers that remain, well, one is the complicated cases, and the second thing is that these finalizers are all in the desktop area. And the people who would be involved in helping clean them up are the same ones who are working on removing applets.
You get the point.
Yeah.
Okay.
So there's one of the surprises.
Just remove AWT and swing.
Yeah. Just remove all this stuff.
Just keep killing stuff until we're like no work is left.
Yeah. And so one of the surprising things, and maybe it's not so surprising, but I mean, it's interesting to experience it. Removing things actually is a lot of work.
Yeah, it's more cleanly.
Yeah. Well, I think part of this whole thing about stewardship, proper stewardship of the platform, is yes, we have to do it clean.
Of course. Yeah.
And so that takes time and effort, but it does free up, the technology and the resources to move on to bigger and better things in the future.
Yeah. Actually, our next guest, we're going to talk about bigger and better in the future. But now we have unfortunately for the security manager, we picked maybe the most interesting topic. Yeah. We have a minute.
Oh no, we summed it up already? Okay.
So Stuart, give us the Cliff's Notes on the security manager deprecation. Let's assume people have a rough idea what the security manager does. Maybe it's more important to explain why it needs to go and what the current state is.
Okay. Well, the security manager, I mean, it's sort of related to Applets, because the fundamental idea of the security manager was, we have a JVM, it has a bunch of code running inside of it. Let's import some code maybe over the network that we don't necessarily trust, or that could be even hostile code, and we import it and run it in the same JVM as all this other code. Well, that sounds pretty dangerous. But the idea is we have the security manager to protect us. So the code that we trust has full privileges. The code that we don't trust has fewer privileges.
Yeah.
And the security manager will manage that. And so this was the big idea around applets, but we already talked about applets, and those are mostly gone. This kind of architecture of loading untrusted code into the JVM was really popular in the late 1990s, and it was built into the JDK in several places. But for the most part, it's not used anymore, and it adds a ton of complexity to the system.
Yeah.
And so all of that stuff has been sitting around in the system, and we've been trying to maintain it, and it's tough. And the fact is, it doesn't do what we want it to do.
It's complicated to use correctly, right? By users,
it's so complicated to use correctly that the number of actual applications that use the stuff correctly is vanishingly small.
Yeah.
And so it's supporting an architecture of downloading code and downloading hostile code into the JVM, which is not something we actually want to do anymore.
Yeah.
If you want to run untrusted code, probably the best way to do that is to create an OS level container and run it inside of that. And then, if something goes wrong, you just kill the container.
Yeah.
And so we don't want to have that in the JVM anymore. But the fact is, we've been dragging along this technology for a couple decades now that is really no longer serving the purpose that it was intended for. And so, we'll take it out.
Yeah, and hence it's going. So the deprecation of security manager is also several multi-step process. I think at current state in JDK 24 is all methods, like all the API is still there, but it's all basically knobs, or it's close to knobs or transparency as it gets. So really doesn't do anything. And the command line flags that enable it, they throw errors now. You can't use them anymore. The reason why the API is there is basically so things don't crash too soon, but it will also go away at some point in the future, right? Like we really fully remove.
A lot of code would have the stylized thing where we say, get the security manager. If it's non-null, then do some security checks.
Yeah.
But if it is null, just do nothing. And so security manager.get or system.get security manager is still there. It returns null. So every code that does that can still call get security manager. It gets a null reference, and it's a no op. It continues to run. So the skeleton of the API and stuff is still there. But if you try to actually instantiate and enable a security manager, you'll get an exception.
Yeah. Okay. Thank you very much, Dr. Deprecator.
Okay.
I said Stuart there.
No,
thank you very much. And we'll be back.